Okay, so we're going to talk about 3D printing today. So first thing is we're going to compare what a two-dimensional inkjet printer to a 3D printer. So as many of you I'm sure have at home, you have a two-dimensional printer which uses paper, and it uses an inkjet print head with the ink cartridge, and the print head rasters the ink onto the paper, and the paper comes out of the printer. So a 3D printer works very different. It uses a 3D plastic filament, which is extruded through a heated print nozzle. And the plastic is printed onto a build platform layer by layer, and the build platform then lowers. And so this is the way that you build up a part. You print each layer on top of each other. So this is just an example. So we take a computer model, and using software, we then slice the model into different layers, and each layer is then printed one at a time in this way. And so here we're printing a frog layer by layer. And each layer is built on top of the previous layer. Just like this. So we can print just about any type of object, but there are certain types of objects that are more difficult to print. And those are objects which have large overhangs. And so shown here are some objects with a 45-degree overhang, and objects which have overhangs of greater than 45 degrees. The printer struggles to print because you need some sort of solid surface on which to print on. And so the software can print different layers of build support structures, which then you can detach from the part. And in this way, we can build some parts with large overhangs. So right now we have the printer going. The printer is printing a space shuttle. And so the first thing that it does is it prints a small Hershey Kiss of plastic. And this is to get the printer plastic flowing. And so in the corner here, it's just printed the Hershey Kiss. And then it starts to print the part, the outline of the part. This is the first layer. And so once it builds the outline, it will then print beginning to print the first layer of the part. So our printer is called the Ultimaker 3. It has two different print nozzles, so it can print with two different types of plastic at the same time. Today we're printing with an orange PLA plastic, which is being extruded at 210 degrees Celsius. The build plate has been heated to 70 degrees Celsius, and so we use a heated build plate so that the first layer of plastic adheres well to the print bed. The first layer of the print is the most important because any imperfections in the first layer will then be multiplied through the subsequent layers, because each layer is printed on top of each other. And this way we print the entire part. So currently we have, this is a space shuttle which is being printed. This part will take about 15 to 20 minutes to print. So it built the outline of the part, and then now it's rastering in with plastic to fill in the solid layer, the first layer. And then subsequent layers it's going to print at a 20% infill, so it'll be partly hollow. And this is done to save plastic and then also to speed up the print time. The first layer was print at a slower build speed, but then the subsequent layers are print at double the print speed. Between each layer, the build platform lowers. The build platform lowers, in this case, it's lowering about 0.4 millimeters between each layer.
How long does it take to train someone in this?
So 3D printing is fairly easy to learn. So in fact, last year at Take Your Child to Work Day, there was a 6th grader who had his own 3D printer at home, and he's playing with it in his room. So it doesn't take a lot of skill, but it does take some there is some learning in how to build certain types of parts, and so sometimes it does take some practice to get the print settings right to build a certain type of part, but with some experience, that's fairly easy to learn.
And what happens with the extra layer of plastic around the outside?
That's just to help get the plastic flowing, and so that's just discarded at the end of the print. So that's the part, and it'll take about 30 minutes to print. But we don't just print toys at NCI, we also do some research. And so what I have here, this is a print that we made. This is a torso of a 1-year-old, and this is called a phantom, and we use this to, this is a representation of the human body, which we use to test imaging devices. So if I open it up here, this is built in 6 different pieces, but the phantom has different regions of the body defined. So we have the lungs here, and then the bone regions, and then also the muscle shown in green here. And so the object of this phantom is that we want to be able to take this phantom down to the clinical center and image it on imaging devices, and it will look like an actual human torso. So we use a special type of plastic here. This is the black plastic contains some iron in it, and that is used to simulate the bones. And so we have here, this is the lungs, these are the ribs, this is the scapula, we have the vertebrae, this small cavity here, that's the esophagus, and this is the sternum, and then we have the outer soft tissue remainder, and this region here, this is the heart. So each of this phantom is built in 6 different pieces. Each piece took about 15 hours to print, for a total of print time of around 90 to 100 hours. And each piece used about 1 whole spool of plastic.
And what are the benefits of using this for research?
So we want to use this for, one benefit is we want to print our own phantoms as a cost-saving measure, because commercialized phantoms are very expensive. But also we want customized phantoms for custom research applications. And so in this case, this is built off of the specific geometry of a specific 1-year-old. And then we can customize that and build our own phantoms for other applications as well. We're also interested in not just imaging. We want to be able to measure the radiation dose received at different positions in the body. And so in future designs, we're going to include small slots where we can insert radiation dosimeters inside of the phantom, so that we can measure the imaging dose received by the patient. And in this way, we can then optimize the imaging protocols in such a way as to keep good image quality while minimizing the radiation dose received by the patient.
And do the colors you pick mean anything, or are different?
So for our case, the colors are not very meaningful. The colors are for radiation attenuation purposes. The color is not really, it doesn't have any meaning to us. So in this case, we chose green, and then we had the black plastic for the bones. So we can go back to our printer here. You can see how the print is doing. We're about 1/3 of the way done. So it's still printing. It's getting up to the... It's just finished printing like the smoke out of the... coming out of the shuttle, space shuttle. And now it's beginning to print the rocket. So it prints each layer and then the build plate lowers of 0.4 millimeters.
Is this one faster than other printers?
So the print speed is primarily determined by the layer thickness, and that also is primarily determines the quality of the print, so the resolution of the print. So it's not so much dependent on the printer, but more the settings that you use to build. And that depends on the quality of the part that you're looking for. So right now we're printing with a nozzle which is 0.8 millimeters in diameter, but we also have nozzles with 0.4 millimeters in diameter that are used for higher resolution printing, and those print parts with finer details.
You mentioned there were repositories where you could have the designs.
So you can go online to find this part was found on thingiverse.com. They're online repositories where you can find models that people have uploaded. NIH also has their own repository called the 3D Print Exchange that have some body parts and other bones and other models that people at NIH have put online to share.
And now it looks like the rocket ship is starting to come together.
Yep, it's almost finished. This last part goes much quicker. So it's printing the part at 20% infill, so it's partially hollow, and that's done to save the plastic, but then also speeds up the print time. Mostly we're interested for this type of part, it's a model, so we're interested on only the exterior of the part, and so we don't care about the interior, and so we can print it at hollow and save plastic, and then also increase the print speed. Okay, the print just finished, so the build plate lowers, and then it starts to cool off. And so right now the piece is still warm, and so it's stuck well to the print build bed. So we let it cool down for a few minutes, and then we can remove the part.
And that's how you make a rocket ship in 15 minutes. So thank you so much for joining us, and thank you so much for being a lovely host, and we'll see you all next Take Your Child to Work Day.
Bye-bye.